Artificial intelligence goes for beginner by knowledge and information. In this video we are discussing about image classification, part 1. Image classification is a process of categorizing or labeling an image into different classes or categories based on its visual content. It is a fundamental task in computer vision that has various real-world applications, such as facial recognition, object detection, medical diagnosis, and autonomous driving. The process of image classification involves training a machine learning model with a set of labeled images. The model learns to recognize the patterns and features in the images that correspond to each category. Once the model is trained, it can be used to classify new images into one of the learned categories. There are various algorithms and techniques used for image classification, including convolutional neural networks, CNNs, support vector machines, SVMs, decision trees, and k-nearest neighbor, KNN, classifiers. CNNs are the most commonly used algorithm for image classification, as they have shown state-of-the-art performance on various image classification benchmarks. One of the important aspects of image classification is the choice of features or descriptors used to represent the image. Traditionally, handcrafted features such as SIFT, SURF, and HOG have been used for image classification. However, with the advent of deep learning, end-to-end learning approaches have become popular, where the model learns to extract features directly from the image. One of the challenges in image classification is dealing with large datasets and ensuring that the model generalizes well to new images. This can be addressed through various techniques such as data augmentation, regularization, and transfer learning. Transfer learning is a popular technique where a pre-trained model is fine-tuned on a new dataset to achieve better performance. These metrics provide information about the model's ability to correctly classify images, detect false positives, and identify all relevant images in a given dataset. In addition to accuracy, other metrics such as precision, recall, and F1 score are also important in evaluating the performance of an image classification model. There are several challenges associated with image classification, which are being addressed through ongoing research. Some of these challenges include 1. Large-scale datasets. With the increase in the availability of data, large-scale image classification datasets are becoming more common. Training models on such datasets is computationally expensive and requires specialized hardware and software. 2. Data imbalance. In some datasets, certain categories may have significantly more images than others, leading to a class imbalance problem. This can result in models being biased towards the dominant classes and performing poorly on the minority classes. 3. Adversarial attacks. Adversarial attacks are techniques used to fool image classification models by making small perturbations to the image that are imperceptible to humans but can cause the model to misclassify the image. 4. Interpretability. While deep learning models have shown state-of-the-art performance on image classification tasks, they are often considered black boxes, making it difficult to understand how the model arrived at its decision. Researchers are developing methods for interpreting the decision-making process of deep learning models. Despite these challenges, image classification continues to be a critical task in computer vision, with numerous applications in various industries. Ongoing research is aimed at addressing these challenges and improving the accuracy and robustness of image classification models. There are many practical applications of image classification across different industries. Some of these applications include 1. Healthcare. Image classification is used in medical imaging to diagnose diseases such as cancer, Alzheimer's, and heart disease. Image classifiers can help detect abnormalities in medical images such as X-rays, MRIs, and CT scans. 2. Security. Image classification is used in surveillance systems to detect and identify objects and people, such as in airport security, border control, and law enforcement. Image classifiers can help detect threats, such as weapons or explosives, and identify suspects. 3. Autonomous vehicles. Image classification is used in autonomous vehicles to detect objects on the road, such as pedestrians, other vehicles, and traffic signs. Image classifiers can help the vehicle make decisions about speed, braking, and steering. 4. Retail. Image classification is used in retail to identify and classify products. Image classifiers can help retailers automate inventory management, identify trends, and optimize pricing. 5. Entertainment. Image classification is used in the entertainment industry to categorize and recommend content to users, such as movies, TV shows, and music. In recent years, there has been a lot of research focused on improving the accuracy and efficiency of image classification. Some of the recent developments in the field of image classification include: 1. Deep learning architectures. Deep learning architectures, such as convolutional neural networks, CNNs, have become the go-to method for image classification due to their high accuracy. Researchers are continuing to develop new architectures that can improve accuracy while reducing computational complexity. 2. Transfer learning. Transfer learning involves using a pre-trained model as a starting point and fine-tuning it on a new dataset. This approach has become popular for image classification, as it can significantly reduce the amount of data required to train a new model. 3. Ensemble methods. Ensemble methods involve combining multiple models to improve the overall accuracy of the classification. This approach has been shown to be effective in improving the accuracy of image classification models. 4. Attention mechanisms. Attention mechanisms are used to improve the efficiency of CNNs by focusing on the most important regions of the image. This can reduce the computational complexity of the model while improving accuracy. 5. Self-supervised learning. Self-supervised learning involves training a model on a task that does not require labeled data, such as image colorization or image inpainting. The model can then be fine-tuned on a labeled dataset for image classification, resulting in improved accuracy. There are also some emerging trends in image classification that are expected to have a significant impact in the future. Some of these trends include: 1. Federated learning. Federated learning involves training a model across multiple devices or data centers without transferring the raw data. This approach can help address privacy concerns associated with centralized data storage while still allowing for the benefits of centralized machine learning. 2. Few-shot learning. Few-shot learning involves training a model to classify new objects with very few examples. This approach can significantly reduce the amount of labeled data required to train an image classifier and make it more practical for real-world applications. 3. Continual learning. Continual learning involves training a model on a sequence of tasks without forgetting what it has learned in the past. This can help image classifiers adapt to changing environments and learn new concepts without having to retrain from scratch. 4. Explainable AI. Explainable AI involves developing models that can provide explanations for their decision-making process. This can help improve the interpretability of image classification models and increase trust in their decisions. 5. Multimodal learning. Multimodal learning involves combining different types of data, such as text and images, to improve image classification accuracy. This approach can help image classifiers understand the context of an image and make more informed decisions. In next video, we will discuss about image classification part 2. Another important aspect of image classification is its ethical implications. Thanks for watching. Please like, share and subscribe.